Hi Devesh. Hi Sonam. Hello everyone. Good evening. So let's get started. So we were discussing linear transformation with respect to some other basis, right? Okay. So let's just see that what do I mean by that. So we have let's suppose some linear mapping we have tx equal to ax or something like that, right? It could be anything. For example, tx might be like I mean x means x1, x2, x3 or x, y, z. Let's suppose this is v. Okay, let's suppose this is v, and then let's suppose this is equal to x, anything. Okay, x plus y, y minus x, something like this. Is this linear transformation? Just tell me. Is this linear transformation? Yes, right? So this is a linear transformation. Now, what do we want? We want this linear transformation not in the standard basis. Okay. So if we are writing something like this, if we are taking some vector and then we are, having some linear transformation of that vector. For example, let's suppose this v is xy. Okay. Let's suppose this v is xy. Then this linear transformation we have in the standard basis, but we are also interested to know that what happens if we change the basis. What happens to this linear transformation if we just change the perspective of looking at this linear transformation? Okay, why we want to look at this linear transformation with respect to any other basis, we will just see this later on. Okay, in diagonalization I will just tell you that why we want to look at this linear transformation with respect to some other basis also. I mean, why this change of basis, why this linear transformation, these topics are even important. We will just discuss about it. Okay. So don't worry. But for now, let's suppose this is a linear transformation that we have in a standard basis. Let's suppose A is a matrix associated with this linear transformation. Okay. So if you want, then you can write V here. Doesn't really matter. I mean, you can take any variable or any vector name. So let's suppose it is V. Okay. Then then I said, like, what we can do, we can represent this linear transformation with this matrix A, right? And this is in the standard. This A is called standard matrix. Standard matrix. Now my aim is to basically my aim is to have the linear transformation, but this time I'm little greedy in the sense that I do not want to take the vector from the standard basis. I want to take the vector from any other basis. So let's suppose there is an input basis. Okay. So let's suppose there is an input basis and there is an output basis. Okay. What do I mean by that? I mean to say that this time the linear transformation I'm looking for will take the basis from input v1, I mean in v1 basis, and will give the linear transformation in v2 basis. So which means in summary, what I'm looking for is something like this, right? What I'm looking for is something like this. So you can say that I'm looking for is basically some matrix. Okay, let's suppose M, which takes a vector, but from the basis b1, and then it transform the vector v, and then it gives this transform vector in the basis b2, right? I'm looking for such matrix M. Is this objective clear to everyone? I mean, last time also we have discussed this, but I'm just quickly repeating. Let me know, is the objective clear that what we are looking for? Okay, so we are looking for this M, right? Now let's just see that how we can find this M. See, do you remember the relationship between V with respect to B1 and then multiplied by B1 should be equal to V with respect to standard basis, right? So this should be equal to V. Do you remember this? Right? Similarly, you can say maybe any other vector. Okay, so for example, this if you want, you can. Okay, last time what was the representation of this that we had? Okay. So I think I was calling it X, I was calling it V, I think. Okay. But anyway, let's not worry about it. So basically this is also a vector, right? So this vector holds a similar property, which means if you want, I can use the same notation. Maybe you will not get confused, right? So let me just check what was the notation last time. Yeah, I was calling it X, I was calling it B. Okay. So let's have the same notation. So in the sense that let's just call this transform vector as V. Okay. So uh basically, okay, just a second. Yeah, basically what you can say that it takes this A takes some vector, let's suppose X, and it gives the transformation of that vector, which is V. So what is the relationship between X and V? This is the relationship. Or you can say, this X is nothing but this B is nothing but transformation of X, right? I mean, this is the relationship. Anyway, you can use any notation, doesn't matter. So what I'm trying to say here is that there's X, and X and the transform vector V is having this kind of relationship. But currently I want this, right? Currently I want this X in, I want to give input in B1, and finally this V I'm looking for in the B2. And I'm looking for that what is the matrix that I need to have here. Okay. This is something that I'm looking for. Is the idea clear that what we are looking for? Now let's just see if you can find out this matrix. Okay. So what is the relationship between X, B1 and X? So as you know, this X V1 into V1, right? Multiplied by V1 is equal to normal X, right? Similarly, this V B1, sorry, B2, because I want that in B2, multiplied by the matrix B2 will give you this V. Are these two relations fine to everyone? Okay. So basically, let me do one thing. Let me go to the next page, and then let's just find out the matrix that we are looking for. Okay. So we are looking for this particular matrix. So basically, it will be, you can do one thing. You can write this XV1. Okay. You can write, instead of this XV1, what you can do, you can write it as uh, B1 inverse, B1 inverse X, B1 inverse, or maybe what you can do, yeah, you can just start from this, right? So basically, you can just start from this particular relationship, which is this one. And then you can say, instead of X, what you can do, you can write B1, X of B1 into A. And instead of V, what you can do, you can write B2, B2, V of B2. And then what do you ultimately want? You want this V of B2, right? So what should be V of V2? What should be the V of V2? It will be, you can easily see, this V of V2 will be B2 inverse A B1. This is something we are looking for into X of B1. Let me know if this matrix is okay to everyone, that how to find this matrix. Is this okay? Transformation, Hers is asking, is transformation is between the same vector space. I mean, for example, Rn to Rn. It could be in any vector space, Rn to R3, R3 to R5. It could be in any vector space. It need not to be having input and output dimension same, right? Okay. Okay. You just tell me, is this okay? That how to find this matrix which we are looking for? Now you tell me. See, you have now got two relations, which is V equal to AX, right? This is one relation that you have got, which is fine. I mean, here A is a matrix, but which takes from the standard basis and transform and give in the standard basis. Now there is another matrix, right? What is that matrix? Let's just call it M, okay? Or maybe some matrix here, which takes from B1, and where does it give you? It gives you in the B2, okay? And what matrix it coming out to be? It is coming out to be B2 inverse A B1. So it is coming out to be something like this, right? So this matrix and this matrix are almost similar with just one difference. What is the difference? The difference is that, I mean, these are similar matrices. Just the difference is that it is taking, right? It is taking from the standard basis, giving in the standard basis, and I mean it is transforming, and it is also doing the transformation. But here the transformation that it is doing, it is basically taking from B1 and then finally it is giving in B2, right? It is okay to everyone? Okay. So little bit you might have understood what I'm trying to say. Let me know. Okay. Just acknowledge if you have understood that how to calculate this matrix and what is the job of this matrix. Have you understood that what is the job of this matrix? Right? So the job of this matrix is take input vector in B1 basis, transform and give output vector in B2 basis. Okay. So this is the job of this matrix. Okay. Now let's just solve some questions and then you will get to understand more that how to do this kind of transformation and these things, right? So let's just take this example. For example, this particular matrix, let's suppose if this is B. Now the question is that they are saying, they are saying, let's suppose that, let me just copy all of this on the next page. Okay, so question is saying that this is a transformation, right? This is the transformation which is given, and the corresponding matrix, the standard matrix, corresponding standard matrix that you can also calculate is, I think, this, right? Let's just quickly verify. Is this the corresponding standard matrix? How to calculate the corresponding standard matrix? Do you remember? Okay. So you can calculate the corresponding standard matrix by putting 1, 0, 0. I mean, see, the corresponding standard matrix is nothing but TE1. Do you remember this? TE2 and TE3, right? Right. This is corresponding standard matrix. Okay. So how and why this is the corresponding standard matrix? Because let me just quickly remind you that, see, let's suppose that you have any transformation. Let's suppose T, right? T of x is equal to A of x, right? Now I want to calculate this A. Okay, what is this A? I want to calculate this A. So for that, what I'm doing, I'm putting x equal to E1. I'm putting x equal to E1. Then you will get T of E1 equal to A into E1, isn't it? You will get T of E1 equal to A into E1. So this A into E1, if you multiply, then this is the first column of A, right? So A is nothing but A1, A2, let's suppose, right? And then if you multiply with E1, which is 1, 0, then you will be getting just A1. So you are saying A into A1, just A1, right? Just A1. So finally, A1 is coming out to be TE1. Okay. So now you can see this A1 is coming out to be TE1, right? So this A1 is nothing but TE1. Similarly, if you put in this equation, if you put x equal to E2, then you will be getting TE2 equal to AE2, and AE2 is nothing but A2, right? So basically, this is TE1 and TE2. So if you find out TE1, let's just calculate the standard matrix. E1 is nothing but 1, 0, 0. So if you put, okay, x3 as 0, x1 as 1, then I think that is 0, 3, G, okay, 0, 0, 3, 1, right? It is 0, 3, 1. Okay, they have just alter the order, I think, but yeah, that's fine. So let's just have the standard matrix, which is 0, 3, 1, and then what is TE2? 0, 1, 0. So if you put x2 as 1, everything else is 0. So what you will be getting? This is 0, this is 5, this is 1, right? So okay, 0, 5, and 1, and then x3 as 1. So 4 minus 2 and 4. Okay. Sorry if it is not visible. Probably now, that's okay, right? Now, this, 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 okay, right Okay, see here. Here me transform the B to get. Okay, anyway, so let's just do this question. So this is the transformation which is given to us. So this is the standard matrix. Let's just represent this standard matrix using A, right? Using A. Is this fine to everyone? This standard matrix corresponding to this transformation is coming out to be this. Can you quickly verify if this is correct or wrong? Can anyone quickly verify? See, you need to put as 100. Okay. If you put 100, I think x1 is 1. So this is 1. This is 1. So I think 3 and 1. If x2 is 1, then 5 and 1. Okay. If x3 is 1, then 4 minus 2 and 4. 4 minus 2 and 4. So I think this is correct. Okay. So this is a standard matrix corresponding to this transformation. Okay, great. But what do we want? So let me just write it. This is standard matrix, right? They are saying that input and output basis is same. Okay, they are saying that we want a matrix which takes from this input and gives in the similar basis only. So which means basically this, if you remember, like I won't calculate it again and again. You can just remember b2 inverse ab1, right? Don't worry, this will be very much, you can say, on the fingertips. Okay, just after few examples you will get to know the essence of this. B2 inverse ab1, right? This is the matrix that they are looking for. But here b2 and b1 are same, or maybe you can just say it is just b, right? So let's just put the values. So what is b inverse a and b? I think yesterday also we did the similar question. So this is 031, 051, 031, 051, and 4 minus 2 and 4, right? Okay. So what is B here? Triple one, 110, triple one, 110, 100. Inverse of this, triple one, 110, 100, right? Okay. So let's just find the inverse of this and let's just check what is the correct answer. So let me go to the next page. So this is the metrics that they're looking for, right? Okay. So let's use Wolfram alpha to find the inverse. So inverse is coming out to be 0, 0, 1, 0, 1 minus 1, 0, 0, 1, 0, 1 minus 1, 1 minus 1, 0. This matrix multiplied by that matrix multiplied by this matrix, right? So this is 0, 0, 4, 3, 5 minus 2, 1, 1, 4. And this is 1, 1, 1, 1, 1, 0, 1, 0, 0. Okay. If you multiply, can you multiply and tell me what is the answer you are getting? Okay, this is 3, 5 minus 2, right? Just multiply and let me know what you're getting. Okay, so if you multiply all of these matrices, you will be getting this, right? This is your answer. So finally, this matrix, this particular matrix that we have got and the matrix that we have started with, this particular matrix, what is the difference between these two matrices? Are both doing the transformation? Yes, both are doing the transformation, but this matrix and this matrix are almost similar in just one difference. What is the difference? This is doing the transformation in the standard basis. This is doing the transformation in this some other basis. Okay, in some other basis. Okay, that is the only difference. But yeah, after multiplication, you will getting this. Let's just check the answer. Okay, let's just check the answer. So yeah, this inverse, and I think the answer is written here. Yeah. So final, the answer, the solution sheet says this is the answer. Okay. Yes, this answer. and the answer that we have got are same. Okay, as you can see, the answer that we have that is listed here and the answer that we have got are same, right? Okay, you can just try matching this. Both answers are same. So basically, this matrix that we have just got and the matrix that we have started are same. And it is just that the only difference is that they are doing the transformation in the different bases. Now, let's just do one thing. Let's just try to understand that how we can, easily get this. Okay, if there is any other way to easily get this particular matrix instead of doing the inverse or something. Okay, I mean both are the almost similar way, but the second approach that I'm telling you is little more intuitive. Okay, so this is second approach to get the transformation matrix, right? Do you remember the notation of this matrix? So if you recall, in the last class, I told you one notation. It is, let's suppose, corresponding to transformation T, then it will be from input basis B1 to input basis B2. Do you remember this? In the last class, we discussed this, right? That this is the transformation. I mean, this is the notation of this transformation matrix. Okay, which takes the vector in B1 and gives you the vector in B2. Okay, that is the notation. But let's suppose if both the bases are same, okay, which means just as this example, then what you will say, if both the bases are same, then you will write something like this. Is this okay to everyone? If B1 is equal to B2, so it is just a notation, right? So if both bases are same, we write like this. But they have just little more shortcut notation. If both bases are same, I mean that's fine. You can write like this, but they have just little more shortcut, which is something like this. Okay, if both bases are same, then you can write in this shortcut form. Okay, if both bases are same. Okay, anyway, let's just talk about this matrix, how to calculate this matrix. So let's just first see if you understood the notations. Is this notation fine to everyone? Tell me. Can I say that it takes the input in B1 or B2? It takes the input in which one? B1, right? And then it gives the transform vector of x and that in B2. Is this whole equation notation wise, is this fine? See, x in some vector which I take with respect to B1, and I can also take the transformation of x, and then I'm getting this transformation x with respect to B2. And all of this job is done by this matrix T. Okay. Okay. I hope that's fine. Let me know. Let me know if there is any problem in this. Right. So what we are looking for, we are actually looking for this particular matrix, or how to find this particular matrix, right? Anyway, you have the answer. So what is the answer that you have? Can you tell me? The answer that you have is something like this, right? I mean, you already know this. Where A is standard matrix transformation. A is standard matrix. Okay. I mean, you already know this, this particular notation. Let me know if there is any issue. Let me know if there is any issue with this particular notation. I hope that is fine, right? Okay. Okay. Now let's just try to understand this bit more. Okay. So this is fine. Now let's just try to understand this bit more. Let's just see that what happen if you let's suppose this is basis B1. Okay, maybe this basis B1 is, let's suppose, U1 U2 U3, or just U1 U2. Okay, let's suppose this is U1 U2. This basis B2 could be, let's suppose, V1 V2, or maybe anything else. Okay, let's suppose this is the basis. Now you just tell me, or can anyone tell me this particular thing? If I put, okay, let's suppose if I put x equal to b1, I mean the first basis vector u1. Okay, just for the sake of notation, maybe I don't know which one suits you. You can just take it. Maybe you can take it b1, b2. Okay, just for the sake of notation, let me take it b1, b2. Okay, so let's just take x equal to b1. Can you tell me how all of this will look like? This will be transformation of b1, right? Transformation of b1 with respect to basis. I mean, then I will take the coordinates with respect to basis b2 equal to this t is something that I'm looking for. So currently I don't know. This is a mystery. Currently I don't know. Now this is b1 with respect to the basis b1. Is this fine? Is this particular? If I put x equal to b1, is this equation fine? At least let me know. Now you just tell me. You just tell me what's going to happen. What's going to happen if you're going to write this? Can anyone tell me this is for sure? Can anyone tell me this is for sure 1 0? If you write b1 with respect to this, isn't it 1 0? We have already seen this, right? Let me know. Let me know how many of you have are you how many of you are convinced. I mean, I will tell in complete detail, but for now, just let me know. Okay. So let me just tell you why. Because this b1 with respect to b1, okay, the coordinates with respect to b1 will be. I mean, this b1 you can write. You can write it just nothing but 1 into b1 plus 0 into b2. 1 into b1 plus 0 into b2. In fact, we have done one question there, right? So any vector, if you're writing with some basis vectors, okay, b1, b2, then let's not worry about this b1. Let's suppose this is x. Can you tell me the coordinates of x with respect to b1, b2? Isn't it 1 0? See, let's suppose I have any basis, okay, doesn't really matter. I have 2, 3, 2, 3, 1, 2. You just tell me, let's suppose this is the basis of R2. You just tell me what is the coordinates of 2, 3 with respect to this basis. You will say it is 1 into 2, 3 plus 0 into 1, 2. Isn't it? Is this equation fine? From this, can you tell me the coordinates of this? Okay, this could be x or something. Coordinates of this with respect to this basis. So it should be the coefficients, right? So it should be 1, 0. So coordinates of 2, 3, 2, 3 with respect to its own basis. I mean, with respect to this basis b, it's just 1, 0. Okay. So if I just ask you coordinates of the first basis vector with respect to its own basis, it is always 1, 0. Doesn't really matter what basis it is, right? Coordinates of this, can you tell me with respect to its own basis? It will be, you will say it will be 0 into this and 1 into this, it will be 1, 2, isn't it? So coordinates of this with respect to this own basis is 0, 1. So in general also, you can say if you have any basis, okay, any basis doesn't really matter. Okay, whatever is this basis, maybe u1, u2, u3. You just tell me, coordinates of u1 with respect to its own basis b, coordinates of u2 with respect to its own basis b, coordinates of u3 with respect to its own basis, let's suppose b. What are these coordinates? These are always 1, 0, 0, 0, 1, 0, and 0, 0, 1. Is this okay? Right? I mean, you can definitely try it. So u1 you can write 1 into u1 plus 0 into u2 plus 0 into u3. And that's how you get the coordinate, right? So coordinates of u1 with respect to this basis is 1, 0, 0 only, right? Okay. So that is the reason that if you ask me interestingly that what is this value, then you will say this is b coordinates of b1 with respect to its own basis b1, right? This b1. Then what is this? This is nothing but 1, 0. Okay. This is always 1, 0. Okay. So here you can say that finally, if you are putting x equal to b1, then it is coming out to be, let's suppose this matrix that this is a mystery for now, but let's suppose this matrix is a1, a2. Okay. Then can you tell me that if you multiply this with 1, 0, what you will be getting? A1 or A2 or A1 plus A2, something like that. Can anyone tell me quickly? If you multiply these two, or if you multiply these two, what you will be getting? You will be getting just A1, right? So from here you can say that this is a1, right? I mean, or maybe, I mean, in reverse way I can say that a1 is this. Basically I'm looking for a1. A1 is this, right? So let me just repeat quickly. Okay, you just repeat with me that what has just happened. Okay, let me just repeat everything quickly. Okay, let me know if this is fine. And the objective is to find out this mystery, right? Is this equation fine? All the notations that this is a transformation matrix taking from B1 basis and then ultimately doing the transformation and giving in the B2 basis. Is this notation completely fine to everyone? Okay. Now let's just assume that this matrix is A1, A2. Now you just put, okay, x equal to B1, where B1 is nothing but this basis vector. What you will be getting? It will be transformation of B1, and then you take with respect to B2, and then it is this transform, I mean, this mystery matrix that I'm currently interested in. So maybe I can use the same color to write it for now. Okay. Equal to into x is nothing but your B1. So B1 with respect to B1 itself. Okay. Is this equation fine? Till now, is everything fine? I will relate it to the previous things, which means that whenever we were dealing with the standard basis, is can you put x equal to B1 in this equation? Just let me know. Okay. So this B1 with respect to B1, what it is? The basis vector V1 with respect to its own basis, it is always 1 0, isn't it? So from here, okay, ultimately I have just figured out that this is coming out to be A1 only, and which is nothing but T of B1, and then finally you need to take the coordinates with respect to B2, right? I hope that's fine. Now similarly, let's just do one thing. Okay, similarly, let's just do one thing. Let's just put, okay, let's just put x equal to B2, and let's just see what you are getting. Okay, just I'm putting it randomly. Okay, so you can put any vector. I'm just checking what happens if you are putting x equal to B1. What happens if you are putting x equal to B2? So if you are putting x equal to B2, this is some mystery, right? And then this is B2 B uh, one, right? Now you tell me what is this? This is, see, B1 is nothing but a basis of B1 B2. You just tell me what is this? Isn't it 0 1? Right? Since this is 0 1 and this is nothing but A1 A2, if you multiply this matrix with 0 1, what you will be getting? A1 A2, A1 plus A2, A1 minus A2, what you will be getting? Just try it out. This is the matrix which is A1 A2. This is just 0 1. If you multiply both of this, then it is easy to see that you will be getting A2, right? So you will be getting A2 here. And that was our goal. I mean, I want to find out A1 A2. So finally it is coming out to be, right? So I got our A1, A2. So what are those A1, A2? The A1, A2 that we were looking for is nothing but, okay, the mystery matrix that we were looking for is nothing but A1, A2, and which is nothing but transformation of the basis vector. This is also the transformation of the basis vector. Earlier also these were the same thing. Do you remember it was E1, E2? Do you remember at least? E1, E2, do you remember? We can again quickly drive. Okay, but at least you remember that it was E1, E2 earlier, right? And then just E1, E2. But here the transformation of the basis vector, just like previous one, e1, e2, or b1, b2, whatever was that transformation of the basis vector. But here, one more, you need to take these coordinates with respect to the output basis. Earlier, the output basis was standard basis, so there was no need to take. Okay. So this is the matrix that we are getting. And this matrix has to be exactly same as the matrix that we calculated earlier. So what is the matrix that we calculated earlier? We can verify that this matrix, okay, we will verify that this matrix is same as V2 inverse A B1. This was the matrix we have calculated using some method. This is the matrix that we have calculated using other method. So let me just tell you again that see here, is this okay to everyone, that how to calculate a1 a2 in this case? Just put x equal to e1 e2, right? X equal to e1 e2, you will be getting your a1 e2, isn't it? Is this particular computation fine? How to get capital A, which is te1 and te2, right? Capital A is te1 and te2. I hope that is fine to everyone, right? Okay. Now similarly, just like this, okay. See, I did this to get a1 a2 in the standard basis. Just like this, we have did this one. See, this was the thing that we have done in the standard basis. Just like this, I'm doing this one, which means, okay, this is the equation that I have. Instead of x, okay, earlier I was putting e1, now I'm putting b1, right? And b2. Okay. So in general, what we can say, in general, okay, if input basis is b1, output basis is b2, then the matrix that we get corresponding to this transformation T is nothing but T of transformations of, see, when you take the transformation of the input, I mean basis vectors, you have the all the transformations, right? Transformation of B2 or something like this, right? These transformations, and then also the ultimately this with respect to B2, because ultimately I want in the B2 basis. So this is the matrix that is doing the whole thing. What this is doing? This is the matrix which is doing multiple things. What are the things? Taking the vector in B1, transforming and giving the output vector in B2. Okay. So let's just do one thing. Let's take one more example and let's just try to see if the things are fine or not. So let's just suppose that this is the transformation that we have. Then based on this transformation, can you tell me the standard matrix at least? Okay, standard matrix. Okay, you put x equal to 1, it will be 1, 1, and 0. You put x2 equal to, this time x2 equal to 1, it will be 1, minus 1, and 2. Right? This is the standard matrix. But let's suppose they are looking for something like this. Okay, this is assuming this is minus 1. They are looking for they are looking for the transformation matrix where the input basis is this and output basis is this. Okay, this is 1 1 0, 1 minus 1 0, and then 0 0 1. Right? Let's just calculate it. So there are two ways to calculate it. Let's just do it in both the ways. Okay, let's just quickly do in a directly formula way, which is b2 inverse a and b1. Okay, let's just quickly do this one. So the b2 inverse, I mean, this is 1 1 0, 1 minus 1 0, and then 0 0 1, right? This is a, which is like this, and b1 is 1 1 minus 1 1. Okay, now let's just find out the inverses and all, and let's just see what is the answer that we are getting. Okay, so the inverse I already have with me for this particular matrix. Okay, I calculated it. So it is coming out to be, this particular inverse is coming out to be 1 by 2, 1 by 2, 0, 1 by 2, minus 1 by 2, 0, 0, 0, 1. This is 1, 1, 0, 1, 1, 1 minus 1, 2, and then 1 minus 1, 1, 1. Okay. If you multiply all of this, okay, I already have the answer with me. If you multiply all of this, it is going to be, okay, finally the multiplication of all of this, it is going to be 1, or maybe I can just write in the parts. If you multiply these two, then you will be getting, first you will be getting 1, 0, 0, 1, 0, 2, and then you multiply with 1 minus 1, 1, 1. Then finally you are getting is something like this, okay, 1, 1, 2, minus 1, 1, 2. Okay, so this is the matrix that we are looking for. Now let's just do this particular thing using the other way. So let's just write it second method. What is the second method? Let's just call it matrix M. Okay, so or maybe if you want, you can use the notation which is from B1 to B2. Okay, but this seems like a scary notation. So should I remove or should I keep it in the slides? Okay, maybe I can remove it, or maybe I can keep it little here. Okay, let's just keep it here. Okay, this is just a notation, don't worry about it. ठीक है, तो यहाँ पे I'm interested in finding this M. What was this final answer that we have got? Transformation of the basis vectors. Okay, transformation of the basis vectors is your final thing. So you have two basis vectors, right? Transformation of the basis vectors tb1, tb2, and that too with respect to the new basis, which is b2. Okay, this is what we have figured out, right? I mean, the matrix should be this. So let's just do this. Can you do the transformation of this b1? Tell me t of b1. B1 is this, transformation is this. So x1 plus x2, I think t of b1, maybe I can copy this on the next page, and then you can tell me, okay, so what is t of b1? X1 plus x2, 1 plus 1, I think this will be 2, 0, and then 2x2, which is 2, right? Okay, what is t of b2? X1 plus x2, which is 0, x1 minus x2, I think minus 2, 2x2, I think it is 2, right? Okay. So this is the transformation of these vectors. Now, is this we want, or we want this with respect to b2? Tell me. We want with respect to b2, right? So let's just find out this, right? So these are the transform vectors that we have, but ultimately we don't want this, right? We want these transform vectors with respect to b2. Okay, I mean, ultimately we want this. So can you tell me this 202, this is equal to something into 101, 110, plus something into 1 minus 1, 0, plus something into 001. What are those things? Okay, just hit and trial you can do. I think this is 2, so it should be multiplied by 2. So that's fine. Now let's just check this. It is 0, so equal quantity of this. Okay, I mean, it want to get multiplied with anything. So I mean, 2 is fine here. So this is 0, so equal quantity of this, and this is 2. So I think 2, 2, right? Sorry, 1 1. So this is the first vector that we are getting, isn't it? Now again, let's just find out the second vector, which means, see, this is the first vector. Okay. So the second vector is this. Okay. So I hope that is visible. Second vector is this 0, -2, and 2. Can you tell me what is 0, -2, and 2 here? 0, -2, and 2. If you want 2, I think you will be multiplying by 2. You want -2 here. You want 0 here. So how you can get it? You want -2. This is -1. I think you can multiply by -1. And this is 1, right? Easy. Okay. So you have both of your vectors. What are those vectors? This T of B1 and T of B2 with respect to the output basis B2 you have, right? So you will say that finally you have got both of your vectors. And what are those? This is 1 1 2. This is -1 1 2, right? Let's just check if we have got the similar matrix earlier, which is 1 1 2 -1 1 2. 1 1 2 -1 1 2, right? This was the same matrix that we have got earlier also, isn't it? So earlier we have used this formula directly, but now we have used this particular technique, and both are giving you the same answer. Let me know if that is fine to everyone. I mean, we will do many other examples, but at least as a starting point, is this fine? Okay. So there are two ways, right? One is that if you want the transformation matrix, then you directly, use this formula. Another way is that you use this representation, and both will give you the same answer. Okay. So here, what we are doing in the second thing, we find the transformation of the basis vectors with respect to, and ultimately we manually calculate it, right? Ultimately, we manually find out with respect to B2. Okay. I mean, with respect to B2, the coordinates are this. Let me know if there is any problem with this, or things are fine. Okay. Yeah, yeah. There will be many other examples we will be doing, but at least as a starting point, is this fine? Okay. Okay. Cool. If there is any problem, you can just let me know. Okay. So the final matrix is 1 1 2, right? So the final matrix that we have got is 1 1 2 and -1 1 2, right? -1 1 2. Now let's just take some vector. Okay. So now let's just do one thing. Now let's take x. Okay. This x, let's suppose this is 2 3, some vector, and do the transformation. And do the transformation. Okay. First tell me, can I multiply this x directly into this and do the transformation? Is this a matrix designed for this particular x? Tell me, can I directly multiply this x with this matrix and do the transformation? No, right? Because because this x I'm representing in the standard basis, but first we need this x in the basis of b1. Okay. So see, the transformation was, I think, this one, right? So let's just do one thing. Let's just verify whether the final matrix that we have got is, the expected matrix or not, which means it is doing the job or not. I mean, the it is doing good job or it is not doing the good job. So how we can do this is like this. So what will I do? I will make use of the transformation matrix that we have just got. This is one way to do the transformation. Okay, for this vector, I will make use of transformation matrix. Other way is that, okay. So I will do two ways. Okay, so here for this particular vector, we will have two ways to do the transformation. Okay, so let's suppose way one, since it is a direct, I have the direct vector without the basis of b1. So b1, what we can do the transformation directly, right? Do the transformation. And way two could be, you can say, the way two could be that use the final matrix that we have got, right? So for example, let's just do using way one, okay, without using the final matrix. Can we do that? Tell me. यही तो करते आए थे इतने दिन से. We should be able to do it, which means if this is a transformation, tell me, without using the matrix, can't you just tell me what is the transformation of this vector 2 3? Yes, this is 5 minus 1 and 6, right? This is 5 minus 1 6. Is this okay to everyone? ठीक है. But is this my final answer? See, let's suppose I'm looking for the answer in the basis, okay, b2. I'm looking for, let's suppose, this thing, okay? Suppose I'm looking for in the basis b2, right? I mean, the transform, I want the transformation, but ultimately I'm looking in the b2. So what is the b2? So this is b2, right? Okay, so this is b2. Now, can anyone tell me, okay, can anyone tell me this 5 minus 1 and 6 equal to something into 110 plus something into 1 minus 10 plus, right, something into 001. I mean, with respect to b2, actually I want, right, plus something into 001. So with respect to b2, can anyone tell me? I think this is 2, this is 2 3 and 6, right? Okay. Got it. So, with respect to this, or maybe if you have this, yeah, you can directly multiply with the B2 inverse. That is also fine. Okay, you can directly multiply with the B2 inverse. I mean, take the inverse of this, you multiply this, and then you will be getting these coordinates, the 2, 3, and 6. But that's fine. I mean, I'm just saying like this. So basically, final answer. Okay. So the final answer that we have got is 2 3 6. Is this the final answer? Yes. Why? Because this is the answer of the transform vector x in the basis of b2. This is the final answer, right? Now let's just do. See, is this way one clear to everyone that how we did it? We have our x, we transform it, and then we manually convert it to basis b2. Okay, ठीक है? Now let's just do using wave. Okay, wave one was okay. So let's just do using method two, right? So this is method 2. Method 2 is saying you use the final matrix that we have. So what is the final matrix? This is the final matrix, right? Okay. So let's use this way two using the final matrix that we have got, where X is 2, 3. And what is the final matrix that you have got? Is something like this, right? Tell me, tell me, if I want the transformation of this vector, and then finally I want in the B2, the transformation I want in the B2. Can I multiply these two and get my answer? No, right? Yes. So basically, what will I do? I will represent this X first in B1, because this matrix is not taking the input in any other basis than B1, right? I mean, this is specifically we designed such that it takes in B1, transform and give the output in B2. So let's just first convert in B1. So actually, B1 is this one, right? Can you tell me what should be there such that it is something into 1 1 plus something into minus 1 1? What are the coordinates? Okay. So, I mean, you can do it, but it is coming out to be 3 by 2 and 1 by 2. Okay. You can just verify. This is 3 by 2 and 1 by 2. Cool. So, what you can do that finally, sorry, this is 2, 3. So, here it should be 2, 3. So, this 2, 3 is coming out to be like this. So, finally, you have got x in B1 is is 3 by 2 and 1 by 2. And then what you can do, you can multiply. Now this vector can be multiplied with this particular matrix, and then you will be getting your final answer. Can you just multiply? 112 minus 112 should be multiplied with 3 by 2 and 1 by 2. Just let me know what is the answer that you're getting. 3 by 2 of this and then 1 by 2 of this. You can, just do 3 and 1 and then divide by 2 later on. So it is 3 plus 1, I think 2, but it will be 1. 3 plus again 1, it should be 4, but it is 2. 6 plus 2, 8, and then it is 4, right? 1 to 4. It is 1 to 4. Let's just check whether earlier also we have got 1 to 4. No, 2, 3, 6 we are getting. 3, 3 minus 1. Oh, sorry, it is 5 by 2. Okay, I'm sorry about it. It is 5 by 2. 5 minus 1, 4. Yeah, it is 5 by 2. Okay. So there was the calculation mistake. So this is 5 by 2. So this is 5 by 2. Yeah. Now you do this. What is the answer you're getting? Just let me know. Yeah. 236, right? Okay. It was actually 5 by 2. So anyway, let me quickly correct it. Okay. So you are getting 236, right? So 236 was the answer that we have got earlier also. Okay. So here also, uh, where is that? Yeah, this one, right? So which means the matrix that we have got is actually the correct one. right? So I will summarize everything what I just did here. I will summarize everything. Let me just summarize. See, we have started with this question. Okay, we have started with this question, right? Yeah, we have started with this question, and I want to get the matrix M such that it is with respect to bases b1 and b2. Okay, so what we did to just get the matrix M, we used two ways, right? One of the way is this, another way is this, another way is that I represent this M like this. Are these two ways fine? For any matrix, okay, for any transformation matrix, we can always apply these two ways, either like this or maybe like this. Okay, transformation of the basis vectors with respect to the output basis, or maybe like this. Okay, so using both the ways we have got the same matrix. Okay, so this is the one thing that we have done, that using both the ways we have got the same matrix, this one and 1 1 2 minus 1 1 2, and here also 1 1 2 minus 1 1 2, right? So using two ways we have calculated our matrix, right, which is the transformation matrix. Now I want to check for any arbitrary vector, okay, x2 3, is this transformation matrix good one or not? So for that, I again did two ways. Way one is that since this is in the standard basis, so I can directly use this way one, which means I can directly do the transformation on this, and then I can represent the final vector in B2. Okay, and B2 is that I can use my matrix that I have just got. So if I do this, right, I can represent this. Then if I do this, I'm getting 236. Or if I'm directly using the final matrix, right, which means if I'm multiplying and I'm directly using the final matrix, right, uh, which means that final matrix is this one. And then if I'm using this, so for that I first need to have the coordinates of x with respect to b1, so that I can make use of this matrix. And if I'm multiplying, I'm again getting the same vector, which is 236. Okay, so we have found out this matrix using two ways. We have verified this matrix also using two ways, right? Cool. Is this little bit understood? Now we can do some examples, right? So basically, I hope the idea is clear to everyone that what we are trying to do. Okay. So what are these matrices and how does the transformation is working? If you notice that if this is in the standard, okay, if it is in the standard, representation, then I can directly use the transformation of them on this. I cannot use the transformation if this is in the, let's suppose in some basis B. Okay, I cannot directly use. I have to first convert that to standard basis. If it is in a standard basis, I can directly use the formula of T. Okay, for example, this is the formula of T. I can directly use. And then once I get this, okay, which is this one, then I can represent this in that in the B2. Okay, that is fine. Or maybe I can directly use, directly make use of the matrix, right, that we have got. Okay, let's do one thing. Let's do this question from MIT. Maybe it will be more clear. Okay, I have many questions today, so let's just solve all of the questions so that these things get clearer. That what I want to convey here. Okay, so let's suppose that they are saying there's a linear map. Okay, so the linear map is given like this. I mean, they are directly giving you the standard matrix. Consider these two bases. So they are saying, let's suppose this is input basis. Let's suppose this is output basis. Okay, are these standard basis? Is this standard basis? Are these standard basis? No, right? I mean, these are some arbitrary bases. That is fine. Now they are saying find the matrix representation MF representing F with respect to these two bases. Okay, which means that input is this. This is input basis. This is output basis. As a hint, they are saying, okay, as a hint, they are saying that you can use this. So this C is your output basis. Okay, this B is your input basis. So as a hint, you are saying you can use this formula here, something like this, and B is this, C is this, and A is this. But it is easier to do directly. Okay, I mean there is other way that we can do. So do you want to do this? I think using this at least you can do, right? I mean, is there any problem in directly using the formula? Okay, so let's suppose we directly use the formula. So C inverse AB, if we do it, then it is coming out to be like this. Is this fine to everyone? Okay. Now you can use a second method. Okay. So I will give you the time. You use the second method. What is the second method? Second method is saying that you do the transformation of the input basis, which is V1, and transformation of V2, and then you represent the final vectors in the basis of the C. Okay. And then we can check whether both matrices are same or not. Okay. In fact, at MIT, you can see at MIT they are having, they are having both the methods for the clarity. Okay. So I've taken this question from MIT, and then they are having both the methods at MIT. Also, they are showing both the methods. Okay. In the solution also, they are saying this is first solution. Okay. This is the second solution. In the solution also, they are having both the solutions. So let's not do this one. I mean, this one is calculation heavy, but let's just try to do the other way. Okay. Other way is also, calculation is required to represent finally in this basis of C, but that's fine. You just try to do in the other way. Okay. So let's just do this, right? The transformation of, the input basis vectors. Transformation of B1 means if you multiply B1 with this, you can just do this 0, 2, and 4, right? Okay. Transformation of B2. If you do this is the first vector, which is 1, 2, 3. Okay. Now you represent this 0 to 4 with respect to the basis C. Okay. So okay, if you want, let's suppose 2 you want, right? And then 4 you want. So what are the coefficients here? 2 you want. I think this will be anyway 0. This is 2. This is 2, right? Yeah, 0 to 2. So if you represent this with respect to C, then it is coming out to be 0 to 2. Similarly, if you represent with respect to C, then it is coming out to be, you can do this. This is coming out to be 1, 1, 1. Okay. Yeah. So, or maybe you can multiply the inverse of this basis matrices to change the coordinates, but that's fine. So 0, 2, 2, and 1, 1, 1 is the answer. So yeah, 0, 2, 2, and 1, 1, right? So see, they've also done the same thing. They have done this, and then 0 to 2 they have converted this, and similarly they have done this, right? So there are two ways. Okay, these ways are not manufactured by me. These ways I'm telling you from MIT. Okay, from MIT directly I'm telling you these ways, right? Okay, okay. So is this understood to everyone? Cool, right? So these are the two ways to solve this. Let me know if this question is okay to everyone, because this is the first question that we are taking, and this is the this is the very important, and every other question will be just like this. Okay. So the basics should be clear. See, there will be the input basis, there will be the output basis. There is always two ways to do this, right? Either you can directly apply this, or maybe the other way is also almost similar. I mean, instead of using A, I'm saying that okay, you use the transformation. Okay. And there also we are changing the basis. In this also we are finally changing the basis to C. Okay. Anyway, like both are actually the similar thing, but yeah, just a different way of saying. Let's just do more examples. Okay. If you are not much convinced, let's just do more examples. Let's just see this particular question from MIT. Okay. Let's just say that what they are saying. Do you want to do this question? What they are saying is that, let's suppose V and W are two vector spaces, and then T equal to T is VU is a linear map. Then the matrix representation of T with respect to the basis B1 to Bn of V and the given basis is W. M2 is defined as follows. So basically they are looking for M2. So input basis, okay, this is the input basis, this is the output basis, okay, and then they are giving you the transformation of the input basis vectors, and that too with respect to the output basis. So can you tell me what is T of V1 with respect to the output basis? Let's suppose this is W. Can you directly tell me the coordinates of B1 with respect to W? Here you put J equal to 1, right? It will be alpha 1 1, alpha 2 1, alpha 3 1, like that, right? Alpha M1. Isn't it? Is this okay to everyone? With respect to W, the coordinates of V1. I mean, actually, it was just a paragraph. I've just taken the screenshot of the paragraph and I'm saying it is a question. Okay, I mean, it was a paragraph. So here on the right hand side, I have this answer and something. But yeah, I'm just saying, let's suppose, okay, M is 3. They're saying M is 3. So I'm just putting it as a question, but it was a paragraph at that PDF, right? And what is T of V2? T of V2, you put J equal to 2 with respect to W. If you want with respect to W, already they have given with respect to W, right? So T of V2, you put J equal to 2. It will be alpha 1 2, alpha 2 2, alpha uh, 3. M की value 3 है ना? 3 2. Okay. So these are your vectors. I mean, this is your final transformation matrix. Okay. ठीक है? Is this okay to everyone? I mean, this is just a paragraph that they were having, and I put it as a question. So they are directly giving you this one, and they're just asking you this with respect to basis W. It is nothing but these coefficients, right? Okay. Let's just see this. Again, it was also the paragraph, and I have just taken the screenshot of that paragraph, and I'm just asking you what is this? Just tell me, if T is a linear map, A is M cross N matrix with respect to the standard basis. Okay. So A is with respect to standard basis, right? It is a standard matrix. Okay. Such that TV equal to AV. Let this be the basis. Okay. Let's suppose this is the input basis. Let's suppose this is the output basis. Okay. And this is represented by capital B. Okay. I mean, this matrix, and this is capital C. So you can say that input basis is capital B, output basis is capital C. Now what they are saying, let's just see. Then the matrix representation of T with respect to these bases. Okay. Can you tell me? Let me give you the options. Okay. Let me give you the options. So the option will be option A. Let's suppose it is B inverse AC. This is the option A. Option B, let's suppose C inverse AB. Option C is, let's suppose, A B inverse C. Option D is, let's suppose, okay. Option D is, let's suppose, uh, something like A C B inverse or something like that, right? Tell me which option is correct. Which option is correct? Yes, option B is correct, right? Option B is correct. Okay. Why? Because output basis is C, then C inverse AB is your answer. If B is the input basis. Okay. So let's just see if C inverse AB is the answer or not. Yes, right? Understood? With respect to input and output basis, what is happening? Let's do more questions. You will get to understand more. Okay. Sorry. Yeah. Let's do this question. This question also I have taken from some standard university. Let's just try to solve this question, what they're saying. So they're saying, let's suppose that the transformation is defined something like this. Then find the matrix A, B, B for T with respect to the standard basis. Okay. So first they are saying with respect to standard basis, you find the matrix. And then they are saying some matrix A, D with respect to the standard. Okay. I mean, with respect to this basis and this basis. So this is input and output basis. Okay. Can you do this? Do you want to do this as an homework? Okay. So with respect to standard basis, you can do, right? This is the answer with respect to input, standard basis. With respect to, other basis also you can do this, right? Okay. Yeah. So I think you can do this as a homework. Will this be okay? Because solution is on the next page. Okay. So solution is here, right? I mean, with respect to other basis, as you already know, this kind of solution will be there, right? Or maybe you can find using the other method. I have told both the methods to you. Okay. Now it is up to you which method you are applying. Now let's see this question, which again I have taken from Standard University. Okay. Let's see what they are saying. They are saying find the matrix representation of L with respect to the standard basis of R2 and R3. Okay. So standard basis with respect to standard basis of R2, I mean the input is R2, I think, right? Input is in R2 and output is R3. So with respect to the standard basis, you find out the matrix representation, and then they have some other basis also. Can you do this also as a homework? Let me know. Okay. Answer is on again the next page. So I think you should be able to do, right? I think here smartly. Just tell me they're using, okay, by looking at this, what do you think they're using, the method one or method two? Method one is direct method. Let's suppose direct method, which is, B inverse A, C or something like that. Okay. This is method one. They're using method one or method two? Method two they are using, right? Okay. Anyway, you can use any method. That's fine. I'm just telling you that what they're using, right? Okay. तो ये क्वेश्चन और हो जाएगा एज एन होमवर्क. ओके. So this question also you can do as an homework, because these are just calculation based question. Once you understand the crux of the transformation, then you can do this, right? And anyway the solution is on the next page, so that is why I'm giving you as an homework, right? Now let's just do this question, which I have again taken from some standard university. So what they are saying, let's suppose this is a basis and the linear transformation with the property that they're saying, okay, they're not revealing the basis. They are saying that, okay, if you do the transformation of these bases, then the transformation of this basis vectors you are getting like this, right? If u is a coordinate vector, okay, u is some vector with respect to that basis b, the coordinate vector is this, okay, relative to b. What is transformation of t, transformation of u? That's what they're asking in the standard basis itself. Do you directly have u, or you have u or u in terms of, with respect to capital V, or do you directly have u? You don't have u, right? So okay, you don't even have the transformation, transformation of, in the closed form, you don't have the transformation in the closed form, right? Okay, that's fine. So just try to do this question. Okay. Do you want to try this question? now, and then we will solve it. It's easy question. Just check. Okay, just check if you have this and how to solve this, right? Hers is saying answer is D. Yes, answer is D. Okay, that's correct. Others, you also try. Okay, let me just give you 1 minute and you just try out this question. Okay, so let's just do this. See, this is UB is given to you, right? So you know that B, right? Here, just a second. Let me use the next page. Okay. So you know this B that is given to you is nothing but this UB that is given to you is B into UB, right? UB is nothing but small u. Okay. Or maybe other way. If you want to write this thing here, you can write it, right? Okay. So this is okay to everyone. Let me know if that is fine. Is this fine? Now, this B is nothing but B1, B2, B3, right? So can you say this is nothing but 2B1 plus 4B2 plus B3? Why? Because this is B1, B2, B3, B1, B2, B3. This is 241, right? 241. And hence you will be getting this U as like this. Now, you can take the transformation both side, and then this will be Tu equal to 2 into T of B1 plus 4 into T of B2 plus T of B3, right? And these values are given to you. Okay. So let's just see. Yeah, this is what we are getting, right? Is this okay? Okay, great. Do you want to try this? So if just one basis is given, then input and output, both the bases are same. Okay. If just one basis is given to you, then input and output, both the bases is same. Okay. So by the way, do you remember the representation of that? If input and output, I mean, you can definitely represent like this, B and B, but there is shortcut notation. What is the shortcut? This, right? Do you remember? I told you. Okay. I mean, both are same. Great. Now, I think this is easy question only. Answer is on the next page. So probably you can also try this question, right? These are the answers. So you can try. So tell me, are they using direct method, or they are taking the transformation of the basis vector and then doing this? They're I mean finding the coordinates. They're using the method two, right? They're not using the direct method. I mean that's fine, whichever method you want to use. Okay. Let's see this. What they're saying is an orthonormal basis. Orthonormal basis means all the vectors are perpendicular to each other, and the length of the vectors are also one. Okay. So all the vectors are perpendicular to each other. I'm not sure if that is required. I mean, this information is required for the to solve the question or not. Let's just see. Okay. So the transformation is given like this. Transformation of U1, they are saying is U1 itself. Transformation of U2 is U3. Transformation of U3 is U4. Okay. And transformation of U4 is U2. Something like this is given to you. Find the matrix T with respect to this basis B. Is this okay? Will this be difficult? I think this is easy question. What you need to do, what is the final answer? The final answer should be C, this one, right? With respect to basis B. And then T of U2 with respect to basis B, like this. Can you do this? This is interesting, easy, whatever you like to call. Okay. Just try this. Okay. Just try this. This should be doable. Okay. So have you tried it? I think this is easy one, right? So it is just like, I mean, the transformation vector you already have, and then the coordinates of u1 with respect to u1, u2, u3, u4, right? It is just one. It is just one. All the zeros. Coordinates of u3 will be 0, 0, 1, 0. Coordinates of u4 will be 0, 0, 0, 1. Coordinates of u2 will be 0, 0, sorry, 0, 1, 0, 0, right? This is the final matrix, right? Okay, so Hers has given the correct answer. And yeah, Aditya has also given the correct answer. Great. Okay. So now let's just move to the next question. Okay. This was good, interesting, easy, whatever you like to call, right? Just a second. Let me make a replica of this question and remove the answer from this. So that whenever someone sees this question from the notes, then first they will be seeing this, and then next is the solution. Okay, great. Now let's just move to the next question. So I think this is the answer. Easy question, right? I like this question actually. Great. Let's just see true or false. Okay, this is also very nice. What they're saying, this is a linear transformation and A is a matrix representation relative to the basis C for B and D for W. Okay, so A is some matrix which is with respect to input basis is I think C and output basis is D. Okay, A is some matrix which is doing the transformation with respect to these bases. Suppose B is another basis and E is also another basis, and S is the change of matrix from B to C, and P is the change of matrix from D to E. Okay, so what they're saying that B is another basis. So for B, there is another basis, capital B, and for W, there is another basis, let's suppose capital E. S is change of basis from B to C. Acha. So here we have two bases. Maybe I can just go to the next page. So here for capital B, okay, there are two bases, I think, B and C. For capital W, there are two bases, D and E. Right? Now they're saying there is a change of basis matrix as with the change of basis from this basis to this basis, and P is a change of basis from this basis to this basis. Okay. They're not doing the transformation, they're just changing the basis. The matrix representation of T relative to B and D. So they want something like this. Okay. If you already have from here to here, okay, from here to here, you already have capital A, right? They want from here to here. Will it be A into S, S into A? Can you just see if it is true? Just check this question and let me know if first one is true, second one or like that, right? This is interesting question, I think. Just try. This is a good question. It will clear all of your concepts related to change of basis, linear transformation. Everything is mixed here. Okay. So you want to go from B to D. I mean, the given vector is in B. So the given vector is in B, right? So what you will do, if given vector is in capital B, you will multiply by the S, right? So that it gets you to the capital C. And then from capital C to capital D, right? You will multiply by A. Then finally you have the capital D. Okay. It seems true. Actually, it is true. Okay. So this A is true. I'm just quickly, solving it. You just solve other options. Let me just wait for one more minute. You just solve other options. Okay. You just check that, okay, what is the input vector? Input vector is in which, basis, and where do we want the output vector? Okay. So let's just check, right? So let's just check with each option. This A is saying the matrix representation of T relative to B and D. Okay. So they want from B to D, right? Yes, it should be AS. Why? Because if the vector, okay, the input vector should be in B. I mean, it is in the basis B. Then, if it is in the basis B, then first you will change the basis, right? If it is in the basis B, if the input vector is in the basis B, first you will change the basis using S, and then once the basis is changed to C, then you will be multiplying by A, such that it finally gets to D. So this is the matrix that they are looking for, right? AS. So that is true. The second option is saying the matrix representation of T relative to C and E. Okay, from C to E they want to go, right? From C to E they want to go. So C to E, what they're saying, if you want to go from C to E, if the input is in C, yeah, I think if the input is in C, that's fine. I think you can go with A, right? I mean, you can multiply with A. So basically, if the input is in C, then you can multiply with A. So till now it is fine. Now finally you got D, right? But you want output vector in E. So this particular vector is in D, and then you want the output vector to be in E. So if see this P matrix, let's just check what this P matrix does. P is a change of basis from D to E. Okay, which means if that is in D, then you need to multiply by P or P inverse. So tell me, is this true or false? So Hertz is saying this is true. Hertz, can you tell me why you think this is true? Okay, if you want, you can unmute yourself if you want to speak. So why you think this is true?
Sir, for second part,
Yes.
मतलब मैंने कुछ I basically tried writing some equations and they connected. I can probably dictate them.
हाँ बताइए.
So first thing is that if you want to get the coordinates of tx with respect to d, that is
Hmm.
equal to a times the coordinates of x with respect to c. So ये first equation थी and second
ये
equation.
ऐसे ही ना.
एक सेकंड सर. Yes, sir. Yeah. And
कुछ एक सेकंड मैं समझ लेता हूँ. तो
hmm.
A is a matrix which is basically doing the linear transformation and giving in the D. हाँ, correct.
And second equation is that D से E में अगर आपको because you are given the matrix P between D and E. So second equation
हाँ.
is that if you want to get coordinates of x with respect to D, that is P times the coordinate of x with respect to E.
This is your saying.
Uh, right side maybe, sir, you can put Tx
अच्छा, okay. Okay.
because D and E are for
Right.
W. So
Right, right. Okay. I mean for any matrix. So मैं यहाँ पे x लिख देता हूँ ना, ट्रांसफॉर्मेशन लिखने की जरूरत नहीं है, राइट?
no,
हाँ ठीक
transformation
है.
writing is necessary for
ओके.
this.
ओके. ओके, गॉट इट. सो दैट इज ऑल्सो फाइन. दिस वन, राइट?
Yes, sir. So if you combine the first and the second, left hand side can be written as a times the left hand side in the second equation can be written as a times coordinate vector of x with respect to c.
Okay, just give me a second. Let me go to the next page. So we are solving for this. Let me just move this. Okay. So here, this thing is A into P into T X. I mean, this with respect to E.
So now if you take P in, with, so this is relative to C and E. Uh, yeah, so now you can take P inverse on the left hand side.
Right. Okay. So you're taking X in C, and then if you multiply by A followed by P inverse, then you're getting transform vector of X and in E, right? And
Yes,
that's
sir.
what they're saying, right? So P inverse A. The matrix representation of T relative to C and E. Yeah, input should be in C and the output should be in E. Yes, right. Okay, let's just try to understand this intuitively also. So why this is making sense. So there is some vector you are taking in this particular basis, and whenever you are multiplying with A is a matrix which is giving you in the basis D, right? So A is a matrix, okay, which is giving the transform vector, right? So after the transformation, it will give you in the basis D. So basically, you can say that A is a matrix which takes in C, and yeah, I think that's what you can you have also written. The transfer vector it is giving in D. So this particular thing is in D, the basis D. And then if I want to convert that to basis E, then why we are not multiplying directly with P? Because from basis D to E, if I want to go from basis D to E, yeah. So if I want the transform vector in E, it should be P into P into this, right? No, P is D to E. P is a change of matrix from D to E. Okay, so yeah, mathematically that is correct. No, no, your calculation is correct. That if the transfer vector is in D, then this let's suppose this is the transfer vector is in E. Okay, you multiply by P like this. Oh, sorry, you multiplied P here. So I think there might be some misprint here, as I can think, because ultimately, I mean, seems false, right? So basically, if you are having P inverse A will give you in the D, and from if there is some vector in D, then see this is X, C, multiply with A. and then you will multiplying P, right? Okay, it should be P. I think if it is P inverse, so basically there is some, it should be P inverse here, right? So should be ultimately it should be P. So this is why this should be false. I mean, this is quite intuitive also. I will check if there is anything here, but it seems like it should be false, right? So basically, the matrix representation of T relative to C and E. So basically, if you want C to E, like the transformation from C to E, first you will be multiplying. You take the vector in C, you will be multiplying by A such that you get the transformation, and then from this vector is in D, right? And from the basis D, this vector will be in the basis D because A is something which gives the transform vector in the basis D. And from the basis D, if you want E, then you can directly multiply by P. So it should be PA. If it is P inverse A, then this is false. Okay. Let's just see the last one. The matrix representation of T relative to B and E. So basically, they are saying B to E. So if the vector is in B, then let's just check. The vector is in B. What you will do? You will be first, you want E finally. So what you will do? You will be first multiplying by S because you can convert to C, and then you can multiply by A so that you can transform it, and final vector is in D, and then you can multiply by P, right? So it should be PAS. Okay. I will check if there is any misprinting in this P. Okay. Otherwise, if it is D2E, then it seems like it is also false. Okay. It seems like it is also false. So basically, true, false, false. Right? Is this okay to everyone? Okay. Cool. Now, let's just see more questions. So this is, I think, the similar kind of questions. Let me check something more interesting. Okay. So this is a reverse question that we have here. What they are saying, that find the matrix B so that, okay. So basically they are saying, let's suppose there is a basis B, and they have not given the transformation. Okay. So they are saying that so that the transformation of X with respect to B. So basically they are saying the transformation of X with respect to B is same as B into, so this is, let's suppose, the basis, I mean, this is beta actually, but let's suppose this is, uh, okay, some C or something, or maybe let's just do one thing. Let's just assume this is M, okay? Otherwise, this beta and B is actually confusing. So let's suppose this is M, okay? So what they're asking is that they are asking for this M, okay? What should be this M? Let's just do this question, okay? This is straightforward, I think, right? So they are saying that there's a matrix M which takes X in B and do the transformation, and the final transformation is also in B. And what is the transformation? Uh, okay, just a second. Okay, so I think I copied partial question. The transformation matrix is this, okay? I only copied the partial question, but yeah, that standard matrix corresponding to this is this, okay? So this is standard matrix. Actually, I copied the B part B. As you can see, I copied the B part, but in the A part, they might have given the standard matrix. Otherwise, how it will be possible to do that? So this M is nothing but, this is B inverse AB, right? Using that, you can find out the same. Or maybe you can use method two also, whatever way you like, right? Cool. Do you want to solve all of these questions? So there are few questions which are actually a little tricky and tough also. Do you want to solve this question as a homework? I mean, we can solve, I will be solving all of these questions because actually they're tricky. But do you want to give it a try? This question is nice question. Similarly, all the questions I have now are actually nice questions only. So do you want to give those questions a try? Okay. So Aditya is saying, sir, can you explain the previous question? Which one? This one you're asking? Okay. This is nothing but, I mean, given this information is given to you, it is nothing but they're asking M. Okay. So M is B inverse AB. M is just B inverse AB. Okay. So you can just calculate B inverse AB. That's all. I mean, this is a straightforward question. It is just that I forgot to write this A. Okay. This is given. Okay. All of this is given to you. And this basis is given. They are just asking, what is this M? Okay. Yeah. So let's just do one thing. You can try. Actually, there are two, three nice questions. Maybe you can try this three, four questions. And tomorrow I will be starting with this question. Okay. Tomorrow I will be starting with this question. But before I start this, you can just try out. Okay. Just try out these three, four questions that we have here. And then we will be starting a new topic tomorrow if time permits. The new topic name is similar matrices. Okay. So you might have seen this format, right? What is this format? If the input and output basis is same, then this is a transformation. If A is a transformation matrix, then this is also the transformation matrix. So basically this is A, and let's suppose this is B, then the A and B are similar. Okay. So there's something called similar matrices if they do the same linear transformation relative to different bases. Okay. Relative to different bases. So we will be starting the similar matrices, which will lead to diagonalization. Okay. It will lead to diagonalization, and then once this diagonalization is complete, we will start eigenvalue decomposition and singular value decomposition. So all of this will get linked. And after the similar matrices, I will tell you, I mean, I will be having the slides where I will tell you that why this, change of basis or why this linear transformation was necessary. Okay. You will get to understand after this, similar matrix and diagonalization, that why we are doing the linear transformation in different bases. Okay. And what is the best basis? So as you can see that you can choose any basis to do linear transformation. So we will also see what is the best, okay, best basis for the linear transformation. Okay. It is not the standard basis, by the way, just to reveal the suspense. It is not the standard basis where we should do the linear transformation. Okay. We will see what is the best basis to do the linear transformation. Right. And then we will start diagonalization. So these topics we will start tomorrow. For now you can do one thing. You can just try out these three four questions that I have here. Right. And tomorrow I will be anyway starting with this question. Okay. So just try out from this question. Tomorrow I will be starting from this question. Or maybe if you want, we can try now also. Do you want to try now? So what they are saying, there are two bases. Consider the linear transformation. They have given this, right? This is a good question. Just try it out. Can you tell me the answer here? It is easy also. If you want, you can tell me the answer directly. So find the matrix representing U with respect to. So if they're just giving the one basis, then it means that they are saying the input and output basis is same. Okay. It means that input and output basis is same. Right. So I think A part is easy. Can you tell me? Right. 2 minus 1 and 1 3, right? 2 minus 1 and 1 3. A part is easy. B part is little tricky. I mean, not very much tricky, but yeah, you can also try this B part. How we can do about this B part? You want to find with respect to basis B. Remember, the input basis is also B and output basis is also B. So first you have to calculate L of V1. L of V1. But you don't know L of B1. You only know L of U1. Okay. So first you have to calculate L of B1 and L of B2. And then you need to represent that in the basis V, right? Yes, you can do it. So just try out this question and we will be starting from this question tomorrow. Okay. There are two, three more questions we have. Just try out all of these questions. These are easy questions only, but for your sake of practice, just try out all of these questions. Okay. Just tell me, okay, for now, just tell me, is this true or false? If you are having R5 to R4, then Lx equal to Ax with 5 cross 4 matrix. Is this true? See, this is taking input from 5, right? If you're writing Ax, then it is 5 cross 4, then X must be 4 cross 1, right? So it is not 5 cross 4. It should be 4 cross 5. So that's why false. Every linear transformation is given by 4 cross 5 matrix. Okay. Anyway, some questions are easy, some questions are tough like that. So just try out all of these questions, right? I will put in the slides. Cool. ठीक है. So let's meet tomorrow. Tomorrow we will be starting a new topic, which is most probably we will be able to start diagonalization. I will first finish this similar matrices and then we will be starting the diagonalization. Okay. Thank you. Thank you everyone. Take care. Bye bye.